Hello and welcome to another live session at the Reactors. This session is in collaboration with Learn Live. Before we begin, please take a moment to read our code of conduct. We're all here to learn, so please be respectful of other people's views and opinions. The chat will be open throughout, and we do encourage you all to participate. Today is the first episode of the three-part Azure AI Fundamentals series. In today's session, you will learn all about how to get started with AI on Azure. This session will be led by Amy Boyd, Senior Cloud Advocate at Microsoft, and Victoria Holt, Data Platform Microsoft MVP. This series partners with Microsoft Certified Azure AI Fundamentals certification. If you follow this link, which I will be putting into the chats just now. So if you follow this link will take you to the 30 Days Learn It Challenge, which we are hosting as a part of this series. So by completing the challenge, you can be eligible for 50% off the cost of a Microsoft certification exam. Amy will be discussing this in more detail in her presentation, but with that, I'm now going to hand over to Amy and Victoria, who will lead the session.
Thank you very much, Rav. Wonderful introduction. So hi everyone. Let's get started so I can see my slides on the screen. We only have an hour together and we have a lot to cover. So first things first, who are we? So my name's Amy Boyd. I'm a Senior Cloud Advocate here at Microsoft. But more importantly, I want to introduce my co-presenter. Victoria, do you want to give us a brief overview of yourself?
Yeah, hi, thanks, Amy. Welcome, everybody. I'm Victoria. I'm an enterprise data architect and a data platform MVP. My focus is on data mostly, and I'm really excited to be part of this AI sort of presentation. So I hope you enjoy the session and leave excited about our possibilities of AI.
Oh, love that. And this session, as Rav mentioned, is one of a three-part series we're going to do, but it's all based around the Azure AI Fundamentals certification. So we're going to kick off today here with the first module that sits in that learning path. So get started with AI on Azure. If you want to follow along, do join that link or scan that QR code and maybe favorite this tab to look at after the session. And start going through that certification. This will get you kind of kick-started, and we're going to have a whole lot of conversation to add to it as well, which is great. There we go. I also want to call out our moderator. So I see some of you are chatting in the chat already. So hey, Josh, thank you so much for joining us. Josh is going to be behind the scenes in this case, but that does not mean he's not going to share his wonderful knowledge of the AI space with us as well. So Josh, do you want to introduce yourself very briefly?
Hi, everyone. My name is Josh. I'm a cloud advocate at Microsoft, and I'm excited to be your moderator for today's session.
Fabulous. Josh has a load of links, but also a load of knowledge that he can share with you in the chat. So if you have any questions, don't hesitate, even when me and Victoria are kind of chatting away to share them. And we'll take a look as well, but Josh is definitely there to support you, which is great. As I mentioned, you can follow along. So we're doing Getting Started with AI on Azure. If you go to ak.ms/learnlive, pop in today's date in a backwards format if you're from the UK, and an A on the end, and you'll be able to check out that learning module. Also, QR codes, super handy if you're on mobile devices to be able to just send a link to yourself of this module. And our learning objective in this session is to learn about all the kinds of AI solutions that can make it possible and considerations for responsible AI practices. So that sounds quite sort of high level, but let's break it down. So I'm going to hand over to Victoria. Victoria, you're going to talk to us a little bit about Introduction to AI.
Hey, thanks, Amy. Right, so AI enables us to build amazing software that can empower healthcare, enable people to overcome physical disadvantages, empower smart infrastructure, and create incredible entertainment experiences and even help save the planet. AI has been around since the 1950s and has amazing capabilities. And with my data lens, I'm always thinking about how data is collected, stored, and used for AI. So we have a video to show you, which explains a little bit more about what we're going to be talking about.
Wonderful. So let's play that video.
Artificial intelligence isn't coming, it's here. It's the defining technology of our time. But it's human ingenuity that makes it so powerful. Jane started losing her vision when she was 12.
California Street.
She uses Seeing AI,
I
crept down the stairs and out the door,
which enables her to read and navigate her world. Microsoft AI is helping farmers adapt to climate change,
We can use technology to help feed the world without wrecking the planet.
enabling wildlife conservation,
The ability to use AI really democratizes science. WildMe uses images from any source to help study endangered species.
and creating new ways for people with hearing loss to communicate.
I want the exact same information that my hearing friends have.
It's more than just imitating intelligence or sounding like a human. Microsoft AI is changing every industry, from healthcare
And now you can see these finite details, the relationship with many structures.
to engineering and telecommunications.
We are using artificial intelligence to change the way we are relating to customers.
AI lets us put people first.
The Microsoft tools really enabled us to breathe digital life into an iconic brand persona.
The product that we make is not a thing in a box. Microsoft AI empowers others to create experiences and potential. This is just the beginning.
artificial intelligence, it's just opened up this whole world.
The future we invent is a choice we make.
Thanks for that. So, simply put, AI is the creation of software that imitates human behaviors and capabilities. There are 4 exciting areas covered in this learning module. Anomaly detection, that can automatically detect errors or find unusual activity in a system. We have computer vision, which is the capability of software to interpret the world visually through cameras, videos, and images. And then we have natural language processing, which is the capability for a computer to interpret written or spoken language and respond. And conversational AI, that creates a potential for a software agent to participate in a conversation. So Amy's now going to delve a little further into machine learning.
That is great. Thank you so much, Victoria. So really good sort of description of what AI is. AI is so broad as like a terminology. So what I wanted to do first and foremost was give you some resources to go and read a little bit more as well in this space. So if you go to that link, aka.ms/deep learning versus machine learning, you'll get a little bit more information than we're going to share on this slide specifically, but it will really help you reiterate what is the difference between all these different meanings. So let's start with the box right at the bottom of the screen. So deep learning. Deep learning, you might have heard of. It's actually something that's been really progressive very recently, and it's a subset of machine learning as a whole. It's based on artificial neural networks, and they have an element where they are able to start training themselves because of the way that they look at the data, and we don't necessarily need to have to label all of our data. But deep learning is just a subsection. It's a type of machine learning. So what is machine learning? Well, machine learning is also a subset, but it's a subset of artificial intelligence. So machine learning includes techniques such as deep learning, but it enables machines to improve at tasks with experience. So it allows you to provide it data, find patterns in that data, and then it's able to, with new data, give you answers to that. So how does that relate, though, to artificial intelligence? Because sometimes these words can all be used sort of weaved in and out of each other, but actually they all have very distinct meanings. So artificial intelligence is a technique that enables computers to mimic human intelligence, and part of artificial intelligence, and often, you know, a lot of different techniques that are involved in artificial intelligence include machine learning. However, I always like to say you don't have to include machine learning inside artificial intelligence for it to look like it's mimicking human intelligence. So artificial intelligence is an umbrella. One subsection of that is machine learning, and even machine learning has lots and lots of different sections, such as deep learning, as well as all those other sections that Victoria already covered: anomaly detection, computer vision, natural language processing, and conversational AI. So let's talk. This is a really nice infographic that's on the Learn module. So what's it telling us here? Well, it's telling us that, if we go back to step one, if you have a load of scientists and they have a lot of pictures of different types of flowers, if they feed it into a mathematical equation or an algorithm, it's likely to find different patterns. It's likely to see that something has a certain shaped petal if it's part of a certain category, or something has a certain shaped leaf, or it has a certain height, or something like that. All these things are called features. So once it's found what the patterns are by seeing lots of labeled data, it will then go ahead, build what we call a model, and then we're able to pass new data to that model. And when we do, that model is then easily able to tell us this flower here is Abellus perennius, or whatever that one is in particular. But the key thing is, because it's seen stuff from past experience, labeled data, which is a form of supervised learning, it's then able to go and have a look and make a prediction on what category it could sit in. There's lots of different types of machine learning technology that's available on Microsoft Azure, but one of them is the Azure Machine Learning Service. The Azure Machine Learning Service enables people to quickly and effectively build out their own bespoke machine learning. So you might have heard of building machine learning models with Python or R or Spark type coding languages. And then inside Azure Machine Learning, there's lots of different technologies that allow you to both use, such as automated machine learning or Azure Machine Learning Designer, but also to take your model through to production by using some of the data and compute management capabilities of the cloud, as well as pipelines that allow you to do reproduce sort of repetitive work. So we talked a bit about bespoke learning. We're going to pass back to Victoria to talk about anomaly detection.
Thanks, Amy. So let's understand a little bit more about what anomaly detection is. Imagine you're creating a software system to monitor credit card transactions and detect unusual usage patterns. Well, that might indicate that we have fraud going on. Or an application that tracks automated production line and identifies failures. Or a racing car telemetry system that uses sensors such as engine revolutions, brake temperature, and so on to proactively warn engineers about potential mechanical failures before they happen. So these kind of scenarios can be addressed by using anomaly detection, a machine learning based technique that analyzes data over time and identifies unusual changes. So in Microsoft Azure, the Anomaly Detector service provides an application programming interface that developers can use to create anomaly detection solutions. And you can find out a little bit more if you want to go to the link on the screen, which I think we can probably share in the chat as well for you. So let's explore a little bit more about how that anomaly detection might help in a racing car scenario. So sensors in a car collect telemetry, such as engine revolutions, that brake temperature, and other telemetry. An anomaly detection model is trained to understand expected fluctuations in telemetry measurements over time. Then, if a measurement occurs outside that normal expected range, model reports an anomaly. That can then be used to alert the race engineers to call the driver in for a pit stop to fix the issues before it forces sort of retirement from the race. So this is a really great example about the benefits of AI and using racing cars. So let's now move to the visual world. And Amy is going to share more about computer vision.
That's great. Anomaly detection is a really interesting one, isn't it? The slide with the anomaly detection on it had all of the little spikes and like why it would have detected that. Very, very cool. But that's kind of a service, right? Like it's a service push your data into, and then it will find anomalies in it. Well, understanding computer vision, Microsoft provides a very similar thing. It provides a service that you can tap into to do all of these amazing things. But first things first, what is computer vision? So computer vision is an area of AI that deals with visual processing. So if you ever have something where you have lots of images, possibly video frames, something like that, sketches, scanned documents, etc., all of these different things, PDFs, I know we all like to use a PDF, all of these things can actually be analysed for what's happening in that space. There's also lots of different types of image classifications. I wanted to share a few with you that you might start to see when using some of these services. So the first one, probably the one you come across the most, is image classification. This involves training a model to tell you what's in the picture. And often that picture is going to be quite a specific item. So in this case, a taxi. So you might have a data set that has taxis, buses, cyclists, cars, etc. And what you want to do is, as it goes through a camera, it says that's a taxi, that's a car, that's a bus in that picture at that time. So that's great, right? It's very, very smart. How do we get to this with it training it to understand different things? But we can go even a step further. So there are options inside Microsoft Azure that allow you to do something more specific called object detection. So object detection is where machine learning models are trained to recognize individual items and possibly even multiple items within one picture. So here we can see 2 different buses, 1 car and 2 cyclists. Not only can it recognize that they're in the image, it can actually put a bounding box around them with their own category so that you can really see in the image what's happening. But we can take it even a step further, something even more complex in computer vision, and we can do semantic segmentation. So here what you'll notice, instead of a bounding box, it's literally highlighted the pixels that it recognizes as buses, cars, and cyclists. So it's very, very specific to exactly where that cyclist or where that car is at that point in time on that image. So there were lots of different items of what can we find in an image, how specific can we be, and do we want to have multiple things associated with an image? But there's also what we do as humans, which is we actually interpret what's happening. So in this case, a person with a dog on a street is actually a phrase we might say if someone said to us, explain what's happening in this picture. So maybe the keyword here is explain. So it's analysis. Image analysis allows you to kind of bring together the extraction of tags, but also kind of bring in natural language processing, which Victoria will talk about a little bit more in a moment, and actually bring these 2 things together. So you can actually describe and summarize the scene that's happening. Another specialized form of object detection is to do with face detection, analysis, and recognition. So the ability to locate a human's face, the ability to classify, as well as the ability to do facial geometry, so to understand where the eyes are, where the nose is, where the mouth is, etc. And even recognize people depending on facial features. And again, we have a whole another set. So there are so many different types of image analysis now, all used for different things. So one of our final ones is optical character recognition. Again, I feel like it's the merging of computer vision as well as text processing in order to be able to take text out of an image and then possibly do something with it afterwards. So in this case, understanding the name of the bank, it might also be things like road signs and forms and invoices and receipts and stuff like that. So all of these different types of image analysis can be achieved with different Azure cognitive services inside Microsoft Azure. So a couple of ones to call out. So we have the computer vision service, which is a service we can analyze images and video. We can do those elements of extracting descriptions. We can classify by extracting tags. We can also do object detection by telling you where it is in the image, as well as provide any kind of text about the image as well. So it's quite a broad service. You call it with an API and you get a JSON response back, and then you can take out of it what you want. So that's the Azure Cognitive Services and the Computer Vision API. If you wanted to make this slightly more bespoke, because we've trained that model on a whole variety of different things, but for custom vision, this service allows you to provide your data to train the image classification model. It's actually called transfer learning. So it's built on sort of our global model, and then you can specialize it to your specific images. And if you provide your own images, you can then provide your own image classification or object detection scenarios. So for me, I've built one in the past that recognizes different items from my wardrobe. So whether it was dresses, t-shirts, jeans, shoes, bags, etc., it was trained on my styles. It was trained on my choices, for example. We also have the face service that enables you to build face detection and face recognition solutions. As well as one of the most popular, I think, APIs, cognitive services APIs at the moment, and was in such high demand, is the Forms Recognizer service. So I mentioned you can extract data, which is called optical character recognition, but the ability to extract things like all of the data from invoices, all of the data from receipts, all of the data from illegal letters, whatever it is, you can actually take that out of these, thousands of different forms that you might be receiving as a business, and actually start to automate and analyze the text. And as I mentioned, we'll come on to analyzing text shortly. So I want to show you a quick demo of these in action, because talking about them is very nice. Having pictures on the screen is even better, but seeing them in action is the key here. So in just a minute or so, I'm going to show you a couple of these examples.
I love some of these images. They're really cool, aren't they?
They are good. These are good examples. This is a nice demo under our aidemos.microsoft.com link. And one of the things here, so the first one, analyze and describe. So this one is what's in the image. This is the computer vision service in some senses. So if we click on this one, to me as a human, this is a taxi. So we can see it's saying it's a car here with 100% confidence. One of the interesting ones, you'll notice the confidence values next to some of these different things. And as they start to go down, so taxi, 60% confidence. It's not actually got the word taxi. I think we're missing, part of what's happening here that might identify it. But also things like curb. Now, as a human, I know behind this car here, there is probably curbs because we're in a city environment. It's less confidence, but it's still brought that up as something that's possible. We've got that description. This is a yellow car on a street. And then there's also different things you can do around extracting any, issues. You can do content moderation and stuff like that around, if people are submitting images to a service. So that's kind of one step with analyzing images. We can also read text in imagery. So if I select this picture, related to taxis again, strangely enough, we can see there's just one word, just taxi. Okay, so you might say, well, that's probably quite simple. So let's try another image. I quite liked this one. I think this one really does a good job. We've got 3 different signs with different size text, different color signs, and all laid out very slightly differently. But one thing that it is able to do is pick up the majority of the information that is on these different signs. And then what we can do from here is we could actually take that information. During this information, you also get where it is in the image as well. So you could actually go and do a bounding box around this, which is object detection. Finally, it doesn't just relate to computer generated text. So if we had, this one's a nice one, free hugs on a sign, quite a simple one, very bold writing, easy to read. But we can also do this kind of interpretation with different coloured writing, different decoration on that writing, and even slang, right? We pack 'em to go is not actually how you would spell this kind of thing in English. but it's still able to pick that up and extract it from the image. So that was a few different quick examples of computer vision in Azure. So we had the computer vision service, we had the custom vision service that you're able to submit your own images, as well as being able to extract text from those images. Speaking of which, Victoria, do you want to take us through natural language processing?
Oh, this is one of my favourite areas, I'm afraid. So natural language processing is an area of AI that deals with creating software that understands written and spoken language. It's also known as computational linguistics, that blend of language, machine learning, and artificial intelligence. It's connected with various areas of sentiment analysis, information extraction and retrieval, machine translation, and question and answering. So NLP enables you to sort of create software that can analyze and interpret text in documents, email messages, and other sources. It can interpret spoken language and synthesize those speech responses. It also automatically can translate spoken and written phrases between different languages and interpret commands and determine appropriate actions. We have a great example, Starship Commander, which is a virtual reality game from Human Interact that takes place in a science fiction world. This game uses natural language processing to enable players to control a narrative and interact with in-game characters and Starship systems. So let's have a look at this video now called About Starship Commander.
So think about this. How often are you alive when the dawn of a new medium comes out? I knew that I had to be a part of VR because there are no rules for what VR should be. Starship Commander is a choose-your-own-adventure VR narrative that uses natural language processing, so you can actually have a real conversation with the characters.
I'm Sergeant Sarah Pearson. I've been assigned to your wing today.
When we started making Starship Commander, we had to figure out, how do we get technology that can understand what a person's saying so that we can have these new narrative experiences? We're a science fiction game. We come up with new words. No off-the-shelf software could let us put in custom words.
Who are the Echnians?
In our story, the bad guys are called the Echnians. And every time we said Echnian, it would come up with really weird words that were similar to other things that you would say. And so it would get confused all the time. So we needed to make sure that we could supply our own script. We started using Microsoft Cognitive Services to power the backend of Starship Commander.
Looks cool.
Once we plugged custom speech service into Starship Commander, I had tears in my eyes when I was playing it because it's like, oh my God, this is it. This is the experience we want.
Open the hatch.
Voice print accepted. Welcome, Commander.
You can essentially put your script in there and it knows, oh, these are the ways that people are going to talk. And these are the phrases that they're going to say.
Cool. What's my mission?
It must be something pretty important.
And then the second thing too was the intent detection. With Lewis, you basically give it a couple statements. After you've given it a couple statements, you crunch it and you start typing in your own statements. And it's shockingly scary how good it picks up even stuff that you didn't put in there.
Computer, use autopilot and let's be on our way.
Autopilot engaging.
I've never seen an opportunity like this where there's a wide open playing field. No one's written the rules yet. There's going to be tons of amazing software out there. And I just can't wait to see what other people write.
Oh, I just think that's such a cool video. So in Microsoft Azure, you can use the following cognitive services to build natural language processing solutions, such as text analytics, translator text, speech, and the language understanding intelligence service called LEWIS. The text analytics service can be used to analyze text documents and extract key phrases, detect entities, and even evaluate sentiment and how positive or negative a document is. It is that transformation of unstructured text in documents to structured data that is suitable for NLP algorithms to use, that identifies knowledge and insights at speed, which would be too time-consuming to do or produce unreliable results. So the understanding of semantics, the meaning behind the words and word order is really helpful in many scenarios, such as analysing certain survey responses. So translating text and speech synthesis are also core that feed many products throughout the world. So Amy will now show you an example of how you can use natural language to interact with the AI system using Lewis.
Yeah, so Lewis is a really interesting one, right? Because you've just mentioned the text analytics service and then speech and translation. You can see how actually you can start using all of these different APIs together to form kind of what happened in that video that we just saw about, you know, analyzing text that's being input, understanding it, but then taking action. And that's what Lewis does really, really well. You create a language model and then you tell it what the intent is of that language. So he said like open the hatch or something like that, which, you know, within the computer game makes sense. If someone said that in my real life, I'd be like, what? Like a hen hatch, or, you know, what would that actually mean? So it's really, really interesting to see that it kind of works in context. So I want to show you another context though, where Lewis can be really useful. So hopefully you can see my screen. We were on the computer vision demo. We're now onto our language understanding demo. So same place, aidemos.microsoft.com, well worth going and taking a look at what's available there. So what we can see is if I make a statement here or select a preset suggestion, something will happen within inside this house. So one of the ones I like to tend to type here first is kind of turn all the lights off. So if I apply that, it will go ahead and turn all the lights in the house off. So it did exactly what I said, but that was a very specific context. You're probably saying, yeah, well, you know, do you need AI? Do you need machine learning necessarily to do that? Probably not, right? But what you do need machine learning to do a little bit more of is something like this. Give me mood lighting for cooking. Well, what's that interpreting? Well, mood lighting is low-level lighting. Cooking happens in the kitchen. So what it's done is it's turned on some of the lights quite low in the kitchen. Another good one is I need more light to read my book. So if I click on this one, some light comes on in the bedroom where the gentleman's reading his book, but it says I need more. So if I click it again, I need more light, and possibly even one more time, more light. We can see the light is turning up. So not only is it understanding what information it's being given, it's actually taking an action on that. One of my other really nice ones here, I'm expecting guests. So what might that mean? Well, that means that guests are coming to your front door, possibly. That might, or however you enter your house. So what we'll do is we'll turn on the porch light. Now, we could have said turn on the porch light, turn on the light outside, etc. But I'm expecting guests just shows how flexible and real life these different Lewis models can become. And for any superhero fans out there, you could even have something like call Batman. Batman is a superhero, comic book hero that basically has a bat as a signal when he is out doing missions. And so you can turn on this light and it would be the shape of a bat. And then we could also say something fun like mission accomplished, and that light will turn off again. The key, a little bit of fun there, but the key note is to just say, go and try out these demos yourself. Go to aka.ms/learnlive-lewis-demo to go and try that out. See what else it can do. See what you can ask it and train it to do as well. So up next is conversational AI. Conversational AI, interestingly, we did that little demo as a crossover into conversational AI because the language understanding service is often well used within conversational AI. So conversational AI is a term used to describe AI agents, you might have heard of them, where they participate in conversations with humans. If anyone has heard of the Turing test, that was a very, very early version of the ability to have a conversation. There's also elements of being able to see all different types of conversational AI. So some good examples that people often list. I know I see these in my everyday life. Customer support for products and services is a really big one. I think you see this on a lot of big providers now. I know like my water and my electric company, for example, to light and water my house. They both have an agent that I've chatted with. And one of the nice things there is 70% of probably the different questions that I just want a really quick answer to, like what's my direct debit amount every month, or what's my bill at, or can I submit a meter reading or something like that, is something that I don't necessarily need a human to be activated in. And also for the human who's in the call center, there's a lot of people out there, that other 30%, where they've got a much more difficult problem that needs someone to intervene, make, decisions that make sense, or take a next action or something like that. So customer support is a really, really popular place for conversational AI. Other examples you may have seen, restaurant reservations through websites, not just submitting forms, but actually being able to chat to an agent and just say, can I book a last minute table for 2 tonight if possible? And it would break down that, book your table for 2 on today's date. So today's date currently is the 28th of February, and actually be able to then book that into the back-end system. So connecting these back-end applications and systems to an interface that we're all very used to, which is a chat format. There's also lots of ways that this can be used in healthcare in a similar way, for people to ask questions of a sort of a knowledge base and then be able to make appropriate recommendations of what to do next. So obviously it's not going to necessarily treat you, it's a chat bot, but what it is able to do is maybe recommend what the next steps are. Who is the right person to call next? Who, maybe you should go and see a pharmacist, maybe you should book an appointment with your local doctor, or maybe it's an accident and emergency issue and you need to go and head to for emergency treatment. And also home automation, great example we just saw with Lewis, but also think about those personal digital assistants. We won't say the names because we'll set them off probably, but the two that help you around the house and you can ask them to do things. They're interpreting what you're asking of them. So I want to do another quick demo, again, to bring this to life, this conversational AI element. So if you go to, you can follow along, you can do this yourself, ak.ms/learnlive-health-bot-demo. We can always pop that in the chat, hopefully, as well, whilst I'm going through it. So here we have, that link will actually send you to this page just here. So it actually sits in our research element. And this is our Azure Health Bot. So if we scroll down and click on try a demo for this user experience, what you'll notice is a nice sort of web chat box that we're all very used to probably by now on here. So I'm just going to initiate a conversation, just say hi. Okay, so the bot said, hi, how can I help? I'm not actually sure, not really sure what to say next. So if I put, how can you help me? Maybe, what can you do? I'm asking it 2 questions. It's in quite a chatty format. So it's going to go and interpret, and then it gives me some information back of how do I interact with this chatbot. So I'm here to help answer any health-related questions. So I can't ask him about my shopping choices or this bot, sorry, about my shopping choices or anything. You can ask me things like sinus infection symptoms, my arm hurts, or what type of doctor treats arthritis, or type help for more options. Let's see some of the other options. So now it's telling me how I can interact with this agent. So I can cancel the conversation, I can start the conversation again, I can ask for terms of privacy, I can give it feedback, I can ask it to delete my data. We'll talk a little bit more about responsible AI shortly. But what I'm going to do is I'm going to tell it some symptoms. So I have a high temperature and a headache. Oh, the minute you're on a live stream, you can't spell, can you, and type. Here we go. Okay, so the following symptoms have been registered. So it's interpreted a high temperature as a fever between 100 and 104 Fahrenheit, or as me and Victoria may know it better, 38 to 40 degrees Celsius, and a headache. Okay, so it's going to assess some reported symptoms, and it's going to ask me a few more questions. But interestingly, these questions you'll notice now are not in a text format. I've not got to type anything necessarily. I can actually use these inbuilt functionality of buttons. So I am female and I am 30. So I'll pop that in. And then it's even given me the option to do tick box potentials like this. So I could tick all, lots and lots of different ones of these. I don't think I've had, these all seem quite specific. So I'm just going to click continue. And a lot of these are, potentially emergency situations. No, I've not had any of these. Okay, so then it's saying, is there additional items? Otherwise, type none. You never want to get lost in a chatbot, I always think. So you always want to give that out of saying, well, actually, none of these things work for me. So I'll type none. And then it will continue to assess and ask me more questions before we get to a place where it says, I think you should go and see your pharmacist and grab some headache medication or something like that. Basically, it says, I'm okay. So it's okay, everyone. I'm all right. We don't need to worry about me doing this live stream. So one of the nice things about that demo is it brought together all of these different services. And conversational AI is a place where you can bring Azure Cognitive Services, Azure Machine Learning, all of our conversational language understanding service, etc., into one agent. And that's what I always think is a great way to explain AI also, which is to say AI is an end-to-end experience where a machine is able to mimic human intelligence. So it's not just the model like it would be if you'd used Azure Machine Learning. It's not just the service and the JSON response if you use the computer vision or the custom vision API, for example. It's actually bringing it together into an experience where when I was going through that, I felt like it was human, it was mimicking human intelligence. And that's kind of that definition that we use. Couple of services to mention that we haven't talked about. We've talked about the one at the bottom, the language understanding service. So this ability to train a language model to be really flexible, interpret an intent and take an action like we did with the home automation system. We also want to talk about the Azure bot service because that chatbot is an app. It's an application at the heart of it. And so what it needs to be doing is it needs to be hosted. And so you can host it in the cloud inside the Azure bot service. But what does the Azure bot service give you extra? Well, it integrates with all the backend services such as Lewis, but as well, it will connect you very easily to a lot of channels. So we saw it in a web chat format, but actually recently, some people on my team have been building some stuff around Microsoft Teams. So in that environment where we're chatting to each other all day, you're actually able to integrate your chatbot into that experience where your people are. So if your customers are on social media, go talk to them there. If they're on your website, go talk to them there. And in Q&A Maker, think of it as frequently asked questions. Most businesses might have an FAQ page on their website. You can simply provide that link, and all of a sudden, your chatbot is able to do it's able to interpret and respond to all of your users about all of those FAQs. So all of a sudden, just adding Q&A Maker suddenly makes your bot incredibly intelligent. One thing we're getting to though here, when we talked a bit about things like facial recognition, some people might have gone, "Oh, I've heard about a bit about that in the press," or maybe when we've started to talk about agents and chatbots, and actually when people start interacting with them, people might have heard about them as well in the media. And unfortunately, it's when they don't quite go to plan. And so in this section, we want to talk to you a bit about responsible AI. First things first, let's talk about the challenges and the risks associated with AI. So, Victoria, you picked one of these, right? And you wanted to tell us a little bit of information around it.
Yeah, so I was quite interested in the errors that may cause harm, because I think that's quite an important sort of challenge and risk there. So this is a really great example of those sort of AI challenges. And one of those is if you sort of think about an autonomous vehicle experiencing a system failure that causes a collision. Now, so that collision may cause harm. And we start asking ourselves, well, who is responsible? So do we start thinking about, is it the vehicle manufacturers, software providers, insurance carriers, or even that sort of like human sort of driver? So harm can happen if a system became vulnerable to cyber threats even. So there's so many things that we all need to think about when we're sort of using AI. It's sort of a really important sort of area to sort of cover off, because I think it's just like all these different things are coming from loads of different angles. So I just think it's like really something that we need to plan for as we go forward in any kind of AI system that we're creating.
Yeah, no, it's a great call out, and that covers, interestingly, lots of different categories of responsible AI. Both should you who's accountable? Is it transparent what it can do? Is it transparent also its limitations? What's happening with your data? Whose data was provided? What was it trained on? Which actually links nicely to one I wanted to cover, which is the bias. So bias can actually affect results. That's a challenge. It's not a challenge that is necessarily a solved problem. Bias is a really difficult problem in AI currently. A good example is provided there. So a loan approval model discriminates by gender due to a bias in the data with which it's trained. So there is actually now tools out there. Some of them are part of Azure machine learning that you can start to understand the data that you're feeding in and its biases or its skews before you ever send these models to production. So hopefully that can help as someone on the side of a machine learning engineer or an AI developer. However, bias is kind of a much deeper problem than that. And so what I wanted to do was share with you one of a really interesting keynote that I went to that I think describes bias, classification, and the problems associated with it, and why we see this happening, which really opened my eyes up to how it's such a difficult problem to solve. And it's actually called The Trouble with Bias. It's on YouTube. So actually, if, Josh, if you could possibly post that link in for us to The Trouble with Bias keynote, that'd be super useful. Basically, it was a keynote conference at a machine learning conference that used to be called NIPS. It's now called NeurIPS. Back in 2017, I was lucky enough to be in the room and watch Kate Crawford deliver this session. She's a phenomenal speaker, but she's also incredibly talented in this space. And she talks a little bit about that. She talks about what she can do and why. Where has this bias come from? And obviously, all machine learning models, are trained on data, and data comes from experience, and data comes from the past. And we know that we don't currently live in a completely equitable society necessarily, depending on what part of society you are, etc. And so interestingly, the data we're learning from is something that we've done in the past, but we are asking ourselves, well, is that how we want to do that in the future still? And she'll show you even further back in history as to where we've even come from, and we've just been building on top of things. So highly recommend taking a look at that and understanding a little bit more about bias. But one thing that AI developers can do now is use things like principles to ask questions. So right now, what can you do? You can ask questions of these AI models always. So let's start with the two at the top, recommending a product. You should always ask yourself, am I comfortable with something recommending a product to me? Personally, I am. I'm like addicted to online shopping. And so I'm very, very comfortable with the recommendation. I also feel personally, I have the ultimate decision in the end. What it's providing me is awareness. Sometimes it's not useful, sometimes it is, and I'm able to decide between those two things and then take action. So it feels very comfortable. I'm okay with it. I'm also personally okay with an AI keeping me safe online because I'm not an expert in that space. So if it can, find that there's an adversary in the background and deal with it without me even knowing, I'm more than happy for that. However, an expert in the space might not feel the same way, and so might ask more questions of this. There's also two other elements. If we look down at the bottom, on the driving one, so some of us might have cars now that do assist our driving. They try and keep us in lane. They keep us away from the car in front. They beep at us a lot if we get too close. They might even try and park your car, and which I'm very happy for it to do for me. But one of the things that I haven't yet taken, some of you may have done this, you may have a car that already does this, is actually take my hands off the wheel and just let it drive. So that kind of element of stepping back and leaving it in control of a machine. And so the interesting piece there is a lot of asking questions. I'm like, well, do I have override capability? Where does it work best? Where are its limitations? Like if I drive on a country road in the UK, it's like, a mud path or something with like bushes all around it. Is it still going to be able to work with a similar thing? Or should I not use it in that situation and possibly use it on our highways, for example, where there's much more structured roads? Understanding these questions is incredibly important. And it's the same with healthcare, something that monitors your health. So a wearable device, we're all very used to them. Love the data, love it. But what if it was telling you it was dispensing medication? I'd ask some similar questions. Some of the questions that you might ask yourself are some of these, and they actually come under specific categories and principles: fairness, accountability, transparency, and ethics. So under fairness, you might say, well, what data is it actually trained on? Am I within that data? Does it address my way I'm going to interact with this product personally? Who's accountable? Do I have that override capability? And so in the end, I am accountable for the car or etc. Transparency. Is it clear an AI is being used? This often comes up with conversational AI. Is it clear that it's not a human in a customer service center who's talking with me, and it's actually a chatbot who might be able to pass me on to that human should I need it? And then finally, under ethical, is there these are probably larger questions that we need to ask of the actual idea that we're integrating. Does it have societal implications? What are the protections when there's unintended behavior, etc.? But the key thing me and Victoria talked about is we wanted to get across was, well, what's the next step you take? And we believe there's a couple. One of them, get reading. There's loads of stuff in this area and it's not necessarily a solved problem right now. Go check out that YouTube video. Go check out, what's happening in the space. Read the articles that are based on different new things that happen in responsible AI. But also, if you're someone who's building AI models, there is something that Microsoft has been able to provide, which is these set of 6 principles. These principles are the idea that we can start to guide that questioning. We can start to have diverse teams building products and diverse sets of people testing products as much as possible, and ask ourselves each of these different pillars. So Victoria, you wanted to pick out one that we potentially haven't included yet, right?
Yeah, so I was thinking about another one of those, that principles of sort of reliability and safety. Because AI systems can have a negative impact on well-being of individuals or communities and businesses if they don't operate reliably, safely, and consistently even. So an example of this is in a financial services organization, where AI could be involved in managing an organization's liquidity and underwriting functions. As AI is being used to influence these decisions, it's essential that it functions responsibly with rigorous testing and a deployment management processes to prevent that unexpected performance failures over the entire lifespan of its use.
That's cool. Gosh, there is so much that goes under each one of these titles. Each one of these has a video to play in the Learn module. We won't play it here right now for you, so definitely go take that Learn module, go check it out, go and see what's available. And there's some really amazing people who are describing, absolute experts in each of these pillars and can describe something to you. Inclusiveness is an interesting one, not something you immediately say, fairness, accountability, transparency, etc. But actually, that's a great video where they talk about designing for the 3%, solves for the 97%. I love that quote. I think it's an interesting one, right? Keeping it in mind as you're building it. Same with the privacy and security element. It's a fascinating space where bringing security of data into AI spaces and making sure people aren't, manipulating the models that you're building, sending in false data to get it to learn something different. There's a lot of adversary out there that relates to AI as well, because it's such a popular area. So our key thing is further resources basically in this section. I highly recommend you going to check out all of those different responsible AI principles, have a read through, check out those videos, and check out the Learn module definitely for that section. You can also, Victoria, you picked up this 10 guidelines. Do you want to tell us a little bit about that?
Yeah, that's a really great resource. It's a new white paper that's come out in the last sort of couple of months. And it goes through sort of 10 different, it's got 10 different sort of stages of it, but broken down into sort of 3 sort of steps really: that access and prepare, design and build documents, and validate and support. And it really sort of takes you through all those sort of steps of implementing that AI responsibly. So it's really worthwhile having the read and use it as a tool to help you sort of like implement that responsible AI.
Nice, great stuff. And then the final link is just that keynote I mentioned, The Trouble with Bias by Kate Crawford, one of my favorite ever keynotes, and a wonderful, wonderful description of some of the, to be aware about bias in AI, where it's come from and what we're doing and the people who are working on this in the future. Always part of a Learn Live session is a knowledge check, and we only have a couple of minutes left, so let's get started. If you want to vote, you can actually take part. So you can go and you can scan this QR code if you wish with your mobile device, or you can go to aka.ms/polls. Victoria, do you want to tell us what the question is?
Yeah, so you want to create a model to predict sales of ice cream based on historic data that includes daily ice cream sales totals and weather measurements. Which Azure service would you use? A, Azure Machine Learning, B, the Q&A Maker, or C, Text Analytics?
Okay, so if people start voting, we've got a nice little polling system in the back so we can then see what percentage different people are voting for. So whilst you're doing that, if I break this down a little bit, maybe to help, so if you vote using the QR code or go to aka.ms/polls, I want to create a model to predict sales. So sales tends to be numeric data, amount of sales, cost of sales, total cost, etc. And it's based on historic data. So that's kind of saying I want it to learn from the past and apply to the future, and include weather measurements. That's like an external data set. Which service should I use? Well, I don't think it's text in this case, personally. I actually think it's probably more on the data, the numeric data side. Q&A Maker, it's not really a chatbot scenario. It's not a frequently asked question piece. And so for this one, the answer is, the suspense. There we go. It's actually Azure Machine Learning. If you have your own set of data, you could probably use something called automated machine learning in Azure Machine Learning to do a forecasting problem based on your previous sales of data, based on numeric data. So great first question. On to our second question in our last minute. Victoria, do you want to take it away?
Yeah, so you want to train a model that classifies images of dogs and cats based on a collection of your own digital photographs. So which Azure service should you use? A, the Azure Bot Service, B, the Custom Vision, or C, Computer Vision?
Oh, it's another interesting one. Do vote if you want to take part. Let us know which ones you're voting for from the session. I can see it just here behind the scenes. Okay, let's break this one down in the last 30 seconds that we have here. So I want to train a model, classifies images. Okay, so I wouldn't say it's the bot service. I cross out the bot service straight away. We're talking about images. So we talked about computer vision and custom vision, didn't we? Of dogs and cats, of course, it's the internet, based on a collection of your own digital photographs. That's the giveaway word here for me. I think this one's custom vision because it's based on my own digital photographs. It wants it to classify images of those. So it might be your dogs and cats. It might be a dog shelter or something like that actually wants to classify. I did a hackathon actually with a dog shelter company, and it was incredible. We did exactly this. We used computer vision to understand, custom vision to understand the different types of dogs and cats that they had at this shelter, and also to be able to understand the data behind the scenes of which ones were getting more rehomed, etc. Okay, so we are very slightly over time. Let's wrap this up. There is another question. We won't have time for it. In this module, we've learned about the kinds of solutions that AI can make possible and considerations for responsible AI practices. We have only scratched the surface, but all of this content was based on this exact Learn module that will get you started on the way to understand Azure AI Fundamentals. So if you go to aka.ms/learnlive-2022-02-28A, you'll be able to get to that, or use that handy QR code and maybe drop yourself a little link in your email. Next up in this series next week is all based on computer vision. So if computer vision section wasn't enough for you and you want to learn more, come back this time next week, exactly the same, and we'll continue this learning series. Go and check out the series with that first QR code. Go and check out that specific second episode with that second one. And with that, we'll say thank you very much. Victoria, super co-host, thank you so much for sharing all of your insights on this.
Yeah, and thank you for asking me. Great.
All right. This has been our Learn Live on Azure AI, and we'll see you at the next one.